Hey, advanced math students. Today we're going to be working on lesson 72. This lesson is actually going to be covered over 3 different days here because there's a lot of different material that we're going to be talking about in the lesson with regard to our triangles. Today's lesson is going to be mainly review about some things that we know about triangles, and then the next 2 days' lessons will be our new information, and some of it actually will be review from Algebra 2, and we'll see what we can remember from that information, what we talked about back in Algebra 2. Now, everything that we are going to be talking about in lesson 72 does have to deal with triangles. Now, when you have a triangle, you have 6 principal parts. What are the different parts? What are the pieces that make up or that comprise a triangle? Well, in a triangle, you have 3 sides. That's the definition of a triangle. It's some sort of polygon that contains 3 sides. Well, if your shape has 3 sides, then you have 3 angles as well. The questions that we'll be talking about, we'll get a few of them today, and most of them will be over the next 2 lessons. We'll say to solve the triangle. What does that mean to solve the triangle? It's meaning you need to find any of the missing or the principal parts that you have. Do you have all of the side lengths? Do you have all of the angle measurements? If not, that's what you're going to be solving for in our problem. Now, to help us in that process for solving a triangle, you have to know the length of one side. Notice the title up there at the top in orange. It says one side plus 2 other parts. You must have at least one of the side measurements of the triangle, and then you have to know 2 other parts in order for you to solve. What could those 2 other parts be? Maybe you have the 2 other side lengths, so you have all 3 sides of the triangle. That will be one situation that we'll see, and that one actually won't show up in lesson 72. That will show up in a future lesson where we learn about something that's called the law of cosines. What we're going to see in today's lesson and the next couple days is if you have the one side that's required, you could have 2 angles that you have in the problem. Well, then what are you missing? You're missing one of the angles and you're missing 2 of the sides. So we will be able to find that information. Another situation that we're going to see, we have to be given at least one side length, but we're going to be given another side length, and then we're going to be given one angle. Well, if that is the case, we're just missing one more of the side lengths, and we're going to be missing 2 of the angles in the problem. So I have to have at least one side length if I'm going to correctly solve for any of the missing parts. If I do not have one side length, there's nothing that I can do. Why is that the case? Why do I have to have one side and not just all of the angles? Remember in geometry when we talked about like our SAS and SSS and those different abbreviations about triangle congruence, we never had one that was called AAA. The reason we didn't have one that was called AAA congruence is those triangles aren't the same, they were just similar to each other. I could have a small triangle that has 3 different angles, and I can have a larger triangle that has the exact same 3 angles. Well, if all of the angles matched, but the sides didn't match, there was a ratio between them, those were called similar triangles. Well, I don't want to just be guessing which one that picture is talking about. I need to know for sure, and that's why one of those side lengths has to be set for us in our problem. Now, in today's lesson, we're going to be focusing on just right triangles. What do we know about right triangles? We have to be given a right angle. That's the qualification for it to be a right triangle. Well, according to what we just mentioned, I have to have one side already, and I have to have 2 of the other parts. Well, one of the other parts that we're going to be given then today is the right angle. That's already assumed to be in the picture, so all I'm going to need to know is one extra piece. Either I need to know one more side length, so I have 2 side lengths and the right angle, or I'm going to be given another angle in the picture. So I have one side length already stated, I have the right angle, and I have a second angle. Well, then what are we missing that time? We're missing the 3rd angle, and we're going to be missing 2 of the side lengths in our problem. So I still have to know that one given side that has to be there, and I'm going to have the right angle already today. So there's just one extra piece that we have to be given in order for us to solve. So as I mentioned, we already have the one angle, that's the right angle. We have the one side, so I just need one extra piece in our question. We're going to be working through two examples together today about how to correctly solve in a right triangle. Again, what does it mean to solve? You're looking for all of the missing pieces that you have in the question. So if you would go ahead in your notebook, jot down the following triangle for me. Notice we do have a right triangle, and I am given one of the side measurements. We're given that 4 right here at the bottom. If we weren't given a side measurement, there wouldn't be anything that we could do in this question. What pieces are we missing in this problem? You're missing one of the angles, that's where the letter A is located, and we're missing 2 of the sides, the letter X and the letter Y. Now, when I do these questions, what I like to do is, first of all, I find the piece that I'm only missing one of. So what was I just missing one of? An angle. I was missing one angle and 2 sides. So I'm going to start with angle A. How do I find a missing angle in a triangle? Well, what do we know about triangles? The total of the angles is 180 degrees. In our triangle, we already have 2 angles that are stated to us, the 90 degree as well as the 50 degree that is on the top. So how would I correctly find angle A? I'm going to subtract those 2 out of 180 degrees, and that leaves me that angle A is 40 degrees. Now, something else that you could do, and this would still give you the same answer, is you could have added your 90 and 50 together first. That would have been 140 degrees. And then 180 minus 140 still is 40 degrees. I just showed the subtraction as 2 separate angles instead of adding them together first and then subtracting, but that's okay. I still get the same answer either way in the question. So I know the one missing angle is 40 degrees. Now, as we're working through these questions here today, I don't want to use anything that I solve for. Just in case we made any silly arithmetic mistake, then we're using the wrong answer later on in our question. So I'm actually not going to be using this 40 degrees anywhere else in the question. We're just going to set that off to the side. I found one of the missing pieces of the question. Well, let's go to this next things that we have to find, which are the 2 missing sides. Which side I find first doesn't matter. I can pick whichever one I want to do first. So I decided I was going to find X first in the picture. Well, if I'm going to find X and all I know is one side, well, I can't use the Pythagorean theorem, because to do the Pythagorean theorem, I would have to have 2 sides stated, and I don't have that. All I have is one side here in the picture. So to help me find side X, I'm going to have to use our trig ratios of either sine, cosine, or tangent. Now, this is going way back to our main definitions of sine, cosine, and tangent, that sine was opposite over hypotenuse, cosine was adjacent over hypotenuse, and tangent was opposite over adjacent. When we picked out the ratio that we needed, we always had to start from an angle. Which angle do we want to start at in this picture? It is the 50 degrees. We never started at the right angle when we did our trig ratios, and I don't want to start at A just in case I did anything silly with my arithmetic. So I want to start from the given angle, and that's my 50 degree. In relation to that 50 degrees, the given number of 4 is the opposite side. The X that I'm looking for is the hypotenuse. Which one of my ratios involves the opposite and the hypotenuse? It is the sine ratio. So I said the sine of 50 equals my opposite side of 4 over the hypotenuse of X. Now, to correctly solve for X, there was a little shortcut I had showed you guys, if you remember that. All that we had to do was move the X that was in the denominator out to the front of the question. Then what was in the front of the question got moved down to the denominator. So that means X is equal to 4 divided by sine 50. Now, if you don't remember that shortcut, what you're technically doing on that previous problem is you would multiply the X out of the denominator. So it would say X sine 50 equals 4, and then you would divide the sine 50 over to get the X all by itself. And that's the question that I have up here on the screen, of 4 divided by sine 50. The x is all by itself now, so we can type that division into the calculator. We're going to go ahead and round to the nearest hundredth, so 2 decimal places, and I came up with 5.22 for my answer for x. So again, how did I do that? I had to pick out the trig ratio from the 50. We had the opposite. We were looking for the hypotenuse, and opposite hypotenuse is our sine ratio. We have one more thing to do in our question, and that's finding the value of y. Now, yes, at this point of the question, you do have 2 of the side lengths. You have the 4 that was given to you, and you have the 5.22 for the x that we just solved. Once again, though, I don't want to use today the pieces that I've solved for, just in case I did something wrong within the arithmetic. And if I was going to use the 5.22, I'm using a rounded answer, so it's not going to give me the most exact answer for the letter y. So as I go back to solve for y, I want to use any of the original information that has been given to us. Again, to solve for the y, we're going to have to use trig. In order to use trig, we have to start at the angle, and once again, that's our 50-degree angle. From the 50-degree angle, the 4 is still the opposite side. That hasn't changed. Well, what's the y in our question? It's the adjacent side, because it's right next to the 50. Which one of our ratios involves the opposite and the adjacent pieces? It was our tangent. So I set up tangent 50 equals the opposite of 4 over the adjacent of y. Just like the last question, our variable is in the denominator, so I'm going to swap those two things around, and I have y equals 4 divided by tangent of 50. Typing that onto our calculator, and that gives us that y is 3.36. Now, at this point, if you did really want to check, you do have all 3 sides in the picture and just kind of look at the numbers. We know in a right triangle, the hypotenuse was always supposed to be the biggest piece. The number that we got for the hypotenuse was 5.22. The other 2 pieces that we have are smaller than 5.22 for the sides, so that makes sense so far. Another thing that you can do to kind of make sure that your sides do resemble pretty close to the right numbers is you could use the Pythagorean theorem at this point. You could say 4 squared plus 3.36 squared, those are the 2 legs, is that equal to our 5.22 squared for the hypotenuse? It might not be the exact same number on both sides, because remember we had rounded, but it better be something pretty close. It might say like 37.2 equals 37.26. Well, that's pretty close, and the rounding is why it's just slightly off at that point of our question. All right, let's go ahead and look at one more example today of how we're going to correctly solve in our triangle to find the missing pieces that we have. So in this triangle, we have our given side, there's the 4 again. We're given another side of the 5, so we're just missing one side, that's the letter y. We have our right angle, so we are given one side plus 2 other pieces, the right angle and a second side. So that means we're missing 2 angles in this question. Again, my preference is I always solve for the part that I'm just missing one of. So what am I missing just one of? An angle or a side. I'm just missing one side in this question. So that's where I'm going to start on the problem. Again, that doesn't have to be what you do first. That's just the way that I like to do the question. Well, if I do have a right triangle and I'm just missing one side, how do I correctly find a side of a right triangle? I can use our Pythagorean theorem. So I set up y squared plus 4 squared is equal to 5 squared. Again, I can only use the Pythagorean theorem if 2 sides are already stated in the question and I'm only missing one of the sides of the triangle. Doing our arithmetic gave me y squared plus 16 was equal to 25. I'm going to subtract my 16 over next, so y squared was equal to 9, and then technically I'm square rooting here, so what do I square to get to the number 9? It is 3. So the one missing side that we have in our question is the number 3. Again, I'm not going to use that 3 anywhere else in my question because I don't want to use pieces that I'm solving for just in case we had done anything wrong with our arithmetic. Let's go ahead and go back and find the 2 angles that we're missing, the letters A and the letter B. Which one you find first is irrelevant as long as you find both of them. So I decided I'm going to start at A. Now, in order to find the angles in this picture, you have to use your trig. I can't just subtract from 180 because all I know is one angle. I would have to know two angles if I'm going to do the subtracting from 180 like we did in our first example together. So beginning at the letter A, how do these two given sides of 4 and 5 relate to the letter A? From our angle A, the 4 is the adjacent side and the 5 is the hypotenuse. Which one of our ratios involves adjacent and hypotenuse is our cosine ratio. So I said the cosine of angle A, notice a capital letter for an angle. So cosine of A is equal to 4 over 5. Well, our job is to solve for the A. So I kind of got to get rid of that cosine that's right in front of the letter A. So how did we put that into our calculator? We used the cosine inverse, the one that had the little -1 exponent. So angle A is the cosine inverse of 4 over 5. If I type that in the calculator, again, we're going to round, that gives us that angle A is 36.87 degrees. Again, I do not want to use that just in case I type something in wrong or I picked the wrong ratio. I'll show you at the end how you can check to make sure that your answers do sound reasonable according to this question. We have one last thing to find in this picture, and that is angle B. I'm going to solve for angle B in a very similar situation here. I need to figure out which trig ratio involves the angle B and the two given sides. Well, from angle B, the 4 is the opposite side this time, and the 5 is still the hypotenuse. Which ratio involves opposite hypotenuse? It is our sine ratio. So I set up the sine of angle B equals 4 over 5. If I'm going to solve for B to get rid of the sine, I'm going to do the sine inverse. So angle B is the sine inverse of 4 over 5. Typing that on the calculator, I came up with that angle B is 53.13 degrees. Now at this point, what could I do just to double check my answer? I could add all three of my angles together. We just found that B was 53.13. On the previous question, we knew that A was 36.87, and then we already have the right angle in our picture. If I add those three angles together, they better be 180 degrees or something very, very close, like 179.98 because of the rounding. It better be pretty close to 180 degrees, and it is. Therefore, I know that I have the correct answer in our picture. Okay, so you always have to have one side. You have to have a length set for you in the picture, and then you have to know two other pieces. Today, those two other pieces, one of them had to be a right angle because we had right triangles, and then either we had a second angle or we had a second side in our problem. Now, what we're going to be doing over the next couple days in our lessons is we're going to be looking at something that's called an oblique triangle. An oblique triangle is something that's not a right triangle. Well, if it's not a right triangle, I can't use the Pythagorean theorem to find a missing side. If it's not a right triangle, then I can't use my main definitions of sine, cosine, and tangent to help me find a missing angle. So that's what we'll talk about over the next couple days in our lesson. How would I solve for a missing side or missing angles if I don't have a right angle already in the picture?